Hello everyone, welcome to my lecture. Here in this lecture, I will try to cover one topic, fundamental principle of counting, few examples. Already in the previous lecture, we have got the idea about what is actually fundamental principle of counting. To have the clear concept about this topic, so let's explain few more examples. It will be better for us because permutation and combination is totally based on counting. Okay, if you have the clear concept about counting, then obviously you will be the master of this topic. So this is nothing but counting. Counting means not like that you have to count your fingers. 1, 2, 3, 4, 5. It's not like that. But remember, counting is simple. So how can we will be the master on counting? So let me explain how counting helps us to have the idea about permutation and combination. So remember that fundamental principle of counting will help us to solve maximum number of questions in case of permutation. Permutation or maximum number of questions solve korte amar fundamental principle of counting help kore. So remember fundamental principle of counting. Already we have got the idea about counting. How can we count the 5 fingers 1, 2, 3, 4 like that? How can that means we have the idea about counting, but here little bit different. It will be logical. Okay, two different principles are there on the fundamental principle of counting. One is fundamental principle of counting of addition and another is fundamental principle of counting on multiplication. So in class 11 in permutation and combination chapter, as well as you will get the idea about permutation and combination in probability theory also. In all those cases, you have to apply both the principle. Fundamental principle of counting of addition as well as of multiplication. So now let me explain what is actually fundamental principle of counting in addition and fundamental principle of counting for multiplication by considering a simple example. So that means from the fundamental principle of counting, actually what you have got in the previous lecture, what is the fundamental principle of counting? So let me explain the first question. Okay. Suppose we have 3 panes, pane 1, pane 2 and pane 3. 3 panes we have as well as 2 marker 1 and marker 1. All the objects are distinct. That means 3 panes are of different colors as well as 2 markers are there of different colors. আমি পাঁচটা বস্তু কনসিডার কৰিছো তিনটা পেন আছে suppose white, green and yellow and 2 markers are there black and green like that. Suppose all the objects are distinct. Suppose now we have got one question. How can we count the number of elements? Suppose the question is given that pick any one of, suppose we have to select any one of the 3 objects. Pick any one of them. So listen carefully. Just listen carefully what is the meaning of this sentence. Pick any one of them. That means you have to select any one of the 5 objects. So how many ways you can select any one of the 5 objects? Are you getting my point? That means 5টা object আছে তোমালোকে 5টাৰ ভিতৰত যিকোনো এটা select কৰিব লাগে. You have to select any one of the 5 objects. So how many possibilities are there? কিমানটা ways তোমালোকে select কৰিব পাৰা? How many possibilities are there? Then obviously let's try to count it. So suppose you can select the pane number 1 or you may select second pane or you may select pane number 3. Suppose the panes are numbering as 1 to 3 and the marker panes are numbering as 1 and 2. So how many different ways you can pick? Either you can pick the pane number 1 or you can pick the pane number 2 or you can pick the pane number 3 or you can select the marker 1 or you can select the marker 2. So how many different ways? You have to select any one. Either you can select pane 1 or you can select pane 2 or you can select pane 3 or you can select marker 1 or you can select marker 2. Here we have given the importance on the word or. So whenever the question is totally depend upon the word or, then we can easily do how many different ways you can select a pane? Three different ways. Either you can select a pane 1, or you can select pane 2, or you can select pane 3. So 3 ways. Am I correct? How many different ways you can select a marker? 2 ways. So what is the total number of ways? Plus is equal to 5 ways. This is the fundamental principle of counting on addition. Addition or fundamental principle. Counting of fundamental principle. Why we have added? Because you have to select any one of the total number of objects. Any one. How many possibilities are there? 5 possibilities. 3, total 5 possibilities. So 1, 2, 3, 4, 5. 5 possibilities are there. Okay, that's why we have the total number which will be 5. Can you count me? Either you can select pane 1, or you can select pane 2, or you can select pane 3, or you can select marker 1, or you can select marker 2. Total number of ways will be 5. As we have given the importance on the word or. That is 3 possibilities for pane and 2 possibilities for marker. So total number of ways will be 5. So remember, the basic principle is that OR represents addition. Whenever the situation will be for OR, then it will be addition. Then fundamental principle of counting for addition. Now let us consider another situation. Pick a pen and a marker. Listen, just have a look and think properly. What is the instruction? You have to pick a pen and a marker. Both the objects you have to select. You are not supposed to select one object. You cannot select a pen only. You have to select a pen as well as a marker. So initially, first of all, we will try to select a pen. How many different ways? First of all, we will try to select a pen. After selecting the pen, we will try to select a marker. Suppose you have selected a pen 1. You have to select a pen and a marker. Both the object you have to select. First of all, you have to select a pen. Eta pen select koribo lagibo. Pen select korar pisore tumi eta marker select koribo lagibo. Suppose you have selected a pen 1. Pen to select korar pisore from this object, 3 different objects are there. Out of 3 different objects, you have selected pen 1. After selecting the pen, you have to select a marker. So how many markers are available with us? 2. That is after selecting the pen 1, you can select 2 possibilities are there. You can select marker 1 or you can select marker 2. That is this one. Only 2 possibilities, PM1, P1M1, P1M2. Am I correct? Suppose initially you have selected a pen 1. First pen to select. First pen to select episode, you have to select a marker 1 because the word N is used. N means both the objects should be selected. First of all, you have to select a pen 1. After selecting the pen 1, you have to select a marker. So after selecting a pen 1 from here, how many markers are available with us? 2. So either you can select M1 or you can select M2. That is 2 different possibilities are there. That's your answer will be P1M1, P1M2. Suppose you have selected pen 2. Possibility is there. Suppose this one P1 select koribo, this one P1 select no koribo. Suppose he P2 to select koribo. So after selecting the pen 2, he has to select any one of these 2 marker. That means M1, M2. In the same way, P2M1, P2M2. Suppose someone may select pen 3. In the same way as he has to select a marker once again. That means 2 possibilities are there. Marker 1, marker 2. That means the possibilities are P3M1, P3M2. So what is the total number of ways? How many ways you have got? 1, 2, 3, 4, 5, 6. Actually, whenever the word we have used is N, how many ways you can select a pen? Okay, 3 ways. That means total number of ways of selecting a pen is 3. And how many ways you can select a marker? How many ways you can select a marker? 2 ways. So as both the condition to be satisfied, both the object you have to select, that's the total number of object will be 6. That means here we have given the importance to the word and, which means multiplication. Remember, don't forget the basic principle. Or means addition and means multiplication. Whenever one situation is depend upon the other one event is depend upon the other one, then in that case you have to multiply it. Total number of ways of selecting a pen is 3 and total number of ways of selecting a marker is 2. So 3 to the 6, as you have to select both the objects. But here you have to select any one of these objects. Either pen 1 or pen 2 or pen 3 or marker 1 or marker 2. So total number of ways is equal to 5. That means number of selecting a pen is 3, number of selecting a marker is 2. So 3 plus 2 is equal to 5. In this way we can easily keep the calculator. Remember, fundamental principle of counting for addition, fundamental principle of counting for multiplication. When you have to use multiply, remember whenever we will try to apply the word and, that means a pen and a marker you have to select. But here you have to select either or. Any one of these objects. That means here we can easily apply the word or, but here we cannot apply the word and. Okay, so many different examples are there we can easily consider. So I think you have got when you have to multiply whenever it is totally dependent upon. That means before selecting a marker, the selection of marker is totally dependent upon selection of a pen. Eta pen select kora pasotli marker select koribo lagibo. That means one of them is totally dependent upon. Select you are not supposed to select a pen only. You are not supposed to select a marker only. You have to select both the objects. One is totally dependent upon the other. For example, you can consider another one also. Suppose a person has, it's a good example also. Suppose a person has, suppose 3 socks. Suppose 3 socks. Suppose white, black and green. 3 socks are there and 2 shoes. 2 shoes are there. Okay? 2 shoes are there. So suppose shoe 1 and shoe 2. So how many different ways you can wear, that means you can make pair. Remember, that means obviously in general situation or in normal situation, no one can wear socks only. That means he has to have the proper pair. First of all, he has to wear sock, then he has to wear a shoe. Okay, then what we will do, in that case, we will try to compare. That means first of all, how many possible ways are there that we can select a sock. How many different ways are there? 3 ways are there. After wearing a sock, you have to wear a shoe. So how many different ways? Suppose you have wearing the shoe of white color. After wearing the shoe, you have to wear a sock. So how many different ways you can select any one of these? First of all, wearing a sock of white color, you have to select any one of these 2 socks. That means either you can select sock 1 or you have shoe 1 or you have to select shoe 2. That means 2 different possibilities are there. As wearing a shoe is totally dependent upon the wearing a sock, that's why you have to give the multiplication sign. So total number of ways will be 6. So in this way we try to apply. If the solution is given that either you have to wear a sock or you have to wear a shoe, then obviously 3 plus 2 is equal to 5. But here, how many different ways a student can wear a sock and a shoe out of 3 different socks and 2 different shoes? If n word will be there in the given question, you have to multiply the total possibilities. Number of possibilities of wearing a sock is 3. Number of possibilities of wearing a shoe or selecting a shoe is 2. That's a total number of ways will be 3, 2s are 6. So this is a fundamental principle of counting for multiplication. In this way, we can consider so many different examples. Suppose 5 numbers are there, A, B, C, D, E, 1, 2, 3, 4, 5. Okay? So suppose you have to form a 3-digit number, exactly 3-digit number. Repetition not allowed. Suppose all the digits should be distinct. No digit should be repeated. Kuno digit to be repeat koribo nwariba. How many total 3 digit numbers can be formed? First of all, we will try to fill up this one place. As the number is 3-digit number, that's why I have used 3 different boxes. How many different ways you can select? How many possibilities are there? 5 possibilities are there. So total number of possibilities 5. Suppose I have used 3 here. So as repetition is not allowed, you are not supposed to repeat the digit 3. So that means suppose I have come here. So to fill up this one place, how many possibilities are there? 4 possibilities. Suppose you have used 1 here. So you are not supposed to use 1 and 3 once again. So how many different digits are left with us? 3 digits. Now it is addition or multiplication. Listen, I am going to explain. To form a 3-digit number, form koribar babe, you have to fill up the 100 place. You should have to fill up the 10 place. You should have to fill up the unit place. That means gute tinita place fill up kora to jaruri. You have to fill up this one and this one and this one. You are not supposed to use or here. Yeah, tomorrow the place fill up korile tomorrow 3-digit number paba jabe. If I will try to fill up any one of these 3 places, will you get a 3-digit number? No. That's why OR is not applicable here. To have a 3-digit number, we have to fill up the unit place and 10 place and 1000 place. And is important here. So that's why, what is the total number of 3-digit number, or what is the total number of ways? The 100 place can be filled up in 5 different ways. The 10th place can be filled up in 4 different ways, and the unit place can be filled up in how many ways? 3 different ways. That's the total number of ways will be 60. Okay, so if the question is given, how many 2-digit numbers can be formed? 2-digit number. Then obviously 5 into 4. So 2-digit number is equal to 20. If the question is given, how many 2-digit and 3-digit numbers can be formed? What is the total number of 2-digit and 3-digit number? Then you have to find a total number of 2-digit and 3-digit number. So 2-digit number is 20 and 3-digit number is what? 60. What is the total number of 4-digit number? If the question is given, how many 4-digit numbers can be formed? So first of all, this place can fill up in how many ways? 5 ways. That is, to have a 4-digit number, 4 places should be filled up. The 1000 place can be filled up in how many ways? 5 ways. If repetition is not allowed, you are not supposed to, suppose I have started with 1, that means you are not supposed to use once again. How many places are left with us? How many digits are left with us? 4. So this place can be filled up in 4 different ways. This place can be filled up in 3 and this one is 2. So what is the answer? 120. 4-digit numbers can be formed where repetition is not allowed. In this way, we will try to apply the fundamental principle of counting, of multiplication as well as of addition. I hope at least you are getting my point. Thank you so much for watching this video. Thank you so much.